Assalamu alaikum everyone, and today we are going to be talking about the EZ absolute configuration of alkynes. Before we continue with this video, let's have a little quiz. Name this molecule. Did you get cis-pentuene? Well, then you'd be correct. Now, name this molecule. You see, the problem with using cis and trans for naming chemical compounds is that they're very vague when dealing with higher substitutions. For example, in the molecule I gave, the hydroxyl group is trans to the double bond, whereas the tert-butoxide group is cis to that group. So this is very vague, and that's why this cis-trans isomerism is a very old school method and don't apply today. What is needed is an absolute configuration of alkenes, such as the EZ method. Let's start off with what each of them means. The E in this means entgangen, which means escaped or opposite, whereas Z stands for zusammen, which means together. Now you're wondering, okay, we have these terms. How do we apply it? Well, we use the Cahn-Ingold-Prelog convention. So let's look at that molecule. First, take this carbon. If you magnify it, you can see that this carbon is attached to a carbon group and the implied hydrogens. Here, the carbon is the priority because it's heavier than the implied hydrogen. Then we go to the other side with the other carbon atom and we look at what it's attached to. Here we have an oxygen atom and a carbon atom. Again, hydroxyl, here we say that it is attached to the oxygen, not the hydrogen. The hydrogen goes later in the chain. So oxygen is heavier than carbon, and therefore it is the priority group. If you go back to the full molecule again, you can see that both priority groups are opposite to one another relative to the double bond, which means they are entgangen or an E-alkene. To show that why this is useful, let's take this molecule. We look again at this carbon with the double bond and we see it's attached to a carbon and an implied hydrogen. So the carbon group is the priority. As for here, we know that this carbon is attached to the other carbon and the chlorine atom. Therefore, the chlorine is the priority. As you can see, both of the priority groups are on the same side, which means they're together, aka zusammen. Now let's take a look at a much more complex example to finish the video. So in the carbon on the right, we can easily say that the bromo group will be the priority since bromium is heavier than chlorine. But here we arise to a bit of a problem. Both are carbon atoms, so we have a tie, and when you have a tie, you continue. This is another carbon that is attached to two implied hydrogens and an iodo group at the end, whereas this is a carbon atom with three implied hydrogens, and due to this factor, this group is the priority. Now, if you see, if there was another carbon in this chain somewhere, then the group on the bottom would be the priority since the next atom would be an iodo. So don't get confused when you look at this group and go one at a time. So that's all there is to it. Thank you for watching. Please make sure to like the video and share it to anyone who might need it. And thank you for watching, and I will see you next time. Bye.